Hello students, this is Prakash Sontakke, working as an assistant professor in Electronics and Telecommunication Department, Pimpri Chinchwad College of Engineering. Today I am here to provide an introductory review on the program elective called Wireless Sensor Network. Let us talk about the teaching scheme of this particular subject. It is a 2-credit course and total 2 lectures are allotted, means 2 hours per week. About the evaluation scheme, it has 10 marks for Intel evaluation, 10 marks for MTE, midterm evaluation, and 30 marks for end term evaluation. So total it carries 50 marks. For this subject, it requires a prerequisite, we can call as prior knowledge of the fundamentals of computer networking, then computer networking protocols, as well as the networking devices. We should aware about these basic contents before starting the study of this wireless sensor network. Apart from that, we also need the basic knowledge of digital communication system. These are the course objectives. The first one, to acquaint students with fundamental concepts of wireless sensor network. Second, to introduce the role of sensors in WSN. And third, to demonstrate the use of various protocols in WSN. So initially, student must be able to understand the fundamental concepts of wireless sensor network. What is exactly WSN? What can be the contents or components of WSN? What can be the roles of each component, specifically sensors, in wireless sensor network? And what can be the supporting protocols for designing the WSN? So these can be the course objectives of WSN course. Let us talk about the course outcome. So what is a course outcome? After learning the course, student must be able to know some facts. So let us talk about these facts. The first one, CO1, indicates to describe various concepts, terminologies, and architecture of WSN. So we should know some of the fundamental concepts of WSN, some of the basic terminologies required for designing of WSN, as well as the WSN architecture. The CO2 statement is to illustrate the components of sensor nodes in WSN. So if I am saying WSN is nothing but it's a complex network of physical smart devices. So each device acts as a sensor node. So we should know the components of each sensor node, what it consisting of. Okay, that can be the course outcome too. Third one is to choose appropriate wireless standards and protocols for design of WSN network architecture. So if students wants to design their own topology, we can call it a network of wirelessly connected devices or wireless sensor nodes, then based on the application, which can be the supporting protocols for designing this WSN network. Okay, so we should able to understand the fundamental knowledge of the protocols needed for designing of WSN applications. And final, CO4, to explain key parameters of WSN operating system environment. So once you know what is WSN node, so how it works, we should know this WSN node, how it behaves. So based on the operating system, or operating system can be considered as a tiny operating system or tiny OS. We can also call this a firmware installed in physical devices. So we should aware about the environment, that is the operating system software environment working on the WSN node. So these can be the 4 CO statements. So students should be able to know these 4 concepts after understanding or completion of the syllabus. Let us go ahead. What can be the content delivery methods, CDMs, for this course? So this course is having a theory subjects as well as a practical lab. So for theory, it has CDM 1, 4, 5, 7 and 9. So CDM 1, it is a lecture with interaction. CDM 4 is a demonstration through models, charts, videos, etc. CDM 5 is about the case study based study. CDM 7 is about the presentation, and CDM 9 is about the asynchronous discussion. So these are the content delivery methods for learning the WSN theory course. For lab, the CDM 4 and 9. 4 is nothing but demonstration through model, charts, videos, and 9 asynchronous discussion. Okay, so we are going to use these CDMs for understanding the WSN course. Let us move ahead. Let us concentrate on now the syllabus of this particular course. So it has major total 4 units. So unit number 1 is the introduction and overview of wireless sensor network. It carries total 7 hours. That is the requirement of completion of this particular unit. So what can be the content of unit 1? The challenges for WSN, WSN versus ad hoc networks, enabling technologies for wireless sensor networks, commercial and scientific applications of WSN, and category of applications of WSN. So initially we must be able to understand some of the challenges in WSN. We should aware about all the challenges. What is the major difference between wireless sensor network as well as ad hoc network? Some of the enabling technologies of WSN. We should aware about each and every enabling technology in WSN and the different applications, varieties of applications in different domains. So these are the contents of unit number 1. Unit number 2 is a single node architecture. It requires total 8 hours for the completion. What can be the contents of unit number 2? It is hardware components, energy consumption of sensor nodes, operating systems and execution environment, examples of sensor nodes, network architecture, WSN scenarios, optimization goals and figure of merits, design principle of WSN, service interfaces for WSN, and the gateway concept. So under unit number 2, we'll be able to study what can be the components of WSN node. Means I'm dealing about the hardware components, okay, and how the energy can be consumed by each and every sensor node based on the applications. What can be the different types of operating system installed in each and every node? What can be the examples of sensor node based on the application? How these nodes are placed to form a network architecture, and based on that their optimization goals as well as the figure of merit can be calculated. So that deals with the applications of WSN. Unit number 3, it requires total 8 hours for the completion. That is a physical layer, wireless standards and network architecture. So specifically in this particular unit, we'll be able to focus on some of the wireless standards as well as protocols needed for connectivity, that we can call the wireless connectivity between WSN nodes. What it consisting of? The physical layer and transceiver design considerations in WSN, MAC protocols, fundamentals, MAC protocols for WSN, IEEE 802.15.4 MAC protocol, routing protocols, gossip and agent-based unicast protocols, energy efficient unicast, broadcast and multicast, transport control protocols, traditional protocols, design issues, performance of transport control protocols. So in this particular unit will be totally deals with the wireless standards as well as the protocol needed for designing of any WSN network. So unit number 4, it carries or it requires 7 hours operating systems for sensor networks. It consisting of introduction, design issues, examples of operating systems, node level simulators, performance and traffic management issues, WSN design issues, performance modeling of WSN, and emerging applications and future research directions. So in this particular unit, we will be focusing on the operating system needed, the simulators available, and some of the design aspects of WSN network. So totally for this particular course, the total hour required for completion of the syllabus is total 30 hours required. Let us talk about the teaching scheme for the lab, which is called as Wireless Sensor Network Lab. So it carries a 1 credit, and the lectures required, the practicals, there is a two practicals, and for this particular course has of 25 marks for oral. Okay, and the prerequisite for this particular lab is fundamentals of programming languages, any basic programming language. It might be a C language or Python language, as well as fundamental concepts of computer networks. Okay, these are the prerequisite for this particular lab. What can be the course objective for this particular lab? So these are the 4 objectives. So first, to demonstrate the installation of network simulators, to compare and contrast various network simulators, to be familiar with embedded C or Python coding, and to introduce the WSN application using simulator. So in this particular lab, we're going to perform all the experimentations with the help of software simulators, just like NS2 network simulator. Okay, so in the first, you should know how to install this network simulator. We're going to have the the comparative assessment of different kinds of simulators used for designing of a WSN application. Also, we should able to have the basic understanding of C language or Python language, programming languages, and finally the WSN application, how we are going to design with the help of these simulators. Course objectives, it has total 5 course objectives: to design the WSN applications using suitable simulator, to demonstrate the installation of network simulators, the implementation of routing protocols in network simulator, to illustrate the TCL script for WSN routing protocols, and finally to analyze the performance of WSN nodes. So these are the list of experiment. Total 10 experiments are here. The very first one is the network simulator installation of wireless sensor network. So initially we must know how to install the WSN simulator. Next, we need to write an TCL script for transmission between mobile nodes. If wireless sensor nodes are movable, we can call these the mobile nodes. And if they want to communicate with each other, how to write a specific TCL script for communication between these mobile nodes. So that can be the second experiment. Third one is to write the TCL script for sensor nodes with different parameters. So we need to vary some kinds of technical parameters, and we need to check the impact of it in your existing network, WSN network. That can be your third experiment. Fourth one, generate TCL script for UDP and CBR traffic in WSN node. So we're going to design one sensor network with the help of the UDP protocol, and we'll be going to check the different technical parameters with this particular experiment. And the same way, we'll be going to have the same experimentation, but now we are changing the protocol. Instead of UDP, we can use the TCP protocol. So your fifth experiment is generate TCL script for TCP and CBR traffic in WSN node. The sixth experiment is implementation of routing protocols in NS2 for AODV protocol. So here we are going to design the network, or we can say a kind of routing protocol network, okay, with the help of NS2. Okay, and seventh one, implementation of routing protocols of NS2 for DSR protocol. Okay, so here again we are going to deal with the DSR protocol, but we are going to design that particular network with the help of NS2 simulator. And third one, we are going to design a network for TORA protocol, but again we are going to implement with NS2 simulator. And finally, last but one least, we can have the study and survey of wireless sensor network simulators. So just like a network simulator, you can call this NS2. We are having varieties of different simulators available, called as an Menasim, Contiki, Kuja, Castelia, Sense, TOSIMS, etc. There are varieties of simulator tool, network simulator tools are available in the market. So instead we can use any one and design our WSN application. And finally, introduction of wireless sensor node application and its simulation. So we need to design one specific application on this network simulator. It might be NS2 or it might be any open source simulator available in the market. So these are the total 10 experiments on WSN lab. Let us talk about some of the job opportunities in WSN. After completing or understanding this particular course, so we can have the varieties of job openings. Some of the positions I have listed here. We can call this as a wireless sensor network research developer, wireless sensor network research engineer or lead, wireless sensor network architect, wireless system test engineer, wireless system automation development engineer, wireless or mobile engineer. But this is not limited to, because WSN is needed for the designing of IoT applications also. So once you understand the WSN, it becomes very much easier for understanding the IoT. So we are having lots of different openings, job openings for IoT engineers. Nowadays we know we have the industry 4.0 and there's a tremendous growth in industries. So that is a requirement, huge requirement of IoT engineers. So WS is a major supportive, we can say, the position for IoT development engineers. Okay, so if you know this or you can understand this subject very well, we are having a huge or vast scope in the future. So that's it about this particular course. If you have any specific query about this particular course, you can contact me at any time. Yes, thank you all of you.